Why are my submarine's rudders so weird? Hey, JP here. Why are my submarine's rudders so weird? You know, that's the typical question that everybody gets asked sometime in their life. So if you get asked that question, here are some answers. These are regular boat rudders. This is one of the rudders off the submarine Bellavia. What the heck is going on with this? Today is not rocket science, it's submarine science. This is the submarine Bellavia. One human is on board, but it is completely operated by an AI. It is a true submarine, not a submersible, in that it does not use a support ship. It travels to the dive destination on its own. Well, at least that's for this week's definition of a submarine versus submersible. As a boat that travels horizontally through the water as well as vertically, our sub needs a rudder. There are very specific reasons why these rudders are shaped so strangely. I'm going to show you why our submarines are shaped like a pocket Klingon bat'leth and why there are so many of them. The big reason for all this strangeness is uniform control. I want the same amount of rudder to turn the sub the same amount of direction, regardless whether the sub is being on the surface, underwater, or halfway in between. This is a problem that is unique to submarines. Why would the amount of rudder you need change when you dive? One of the big factors on how big your rudder should be is how much side area there is on your boat. The more side area, the more rudder you need. Now, it's not the side area of the whole boat, it's the side area that's in the water. The big point is that the side area on a submarine changes. Here's the side area of the sub when it's on the surface. Here is the side area when the sub is underwater. You can see that underwater there's a lot more surface area for the rudder to overcome. How do you compensate for that? Well, you can magically make your rudders larger and smaller, or you can live with the fact that you need to kick in a lot more rudder. But what if you need to turn faster and you run out of rudder? You can make the rudder really big, but then you're adding a lot of drag and the steering will be very touchy on the surface when you don't need all that rudder. Add to that, the amount of rudder you need changes constantly while you're surfacing or diving. This makes maneuvering while you're doing those things very tricky. This weird shape fixes all of that. Here is the rudder when the submarine is on the surface. Remember, it's not about how much rudder, it's about how much rudder is in the water. Only this part of the rudder is underwater and doing anything. Here is the rudder when the submarine is underwater. When the submarine dives, it automatically gets more rudder. You just need to work out the amount of rudder you need at each point in the dive and make the top half of the rudder bigger by that amount. That way, when you want to turn the sub 20 degrees to the right, you use the same amount of rudder whether you're on the surface, underwater, or anywhere in between. Time for a commercial break. You can directly support our spacecraft, airships, and submarines on Patreon. The link is in the description. Okay, all that explains this extra bulge at the top. But what about all this sticking out forward like this? The next thing that makes these rudders look weird is balance. You know, it can take a lot of force to move a rudder. You can eliminate a lot of the need for that force by balancing the rudder. This goes all the way back to 3rd grade and Mr. Stuber's Simple Machines class. You were paying attention back there, weren't you? I'm talking about levers. A simple lever that we've all played with is the teeter-totter in the park. On a teeter-totter, you can lift a whole kid on the other side with just a touch of your toes. That's because it's balanced. The fulcrum, or hinge point, is right in the middle. Instead of putting a hinge on the end of the rudder like a regular boat, we put it inboard and make a teeter-totter out of it. You can see this on aircraft all the time. A great example is a World War II biplane. Notice the hinge point isn't right in the middle. If you did that, it would take no force to move. That would make it very touchy. You want some force on the rudder for dampening. On Bell's rudder, we put about 30% of the rudder ahead of the hinge point, offloading about 30% of the force it needs. Here is the hinge point and the section protruding in front of it. Now we have the rudder that gives the same amount of turn, regardless whether it's on the surface or underwater, and a rudder that only needs a moderate amount of force to turn. Now that we have the shape out of the way, why are there 4 little rudders instead of one big one? Again, this is about force, but also about economics. The submarine uses large underwater rated servos to drive the rudders. The bigger the rudder, the bigger the servo needed to drive it. A single big servo is quite a bit more expensive than several smaller ones. Also, by dividing up all the loads, the forces on the components are smaller. This means longer lifetimes between servicing, easier to maintain, and more forgiving all around. It's always a trade between fewer high-load parts versus more low-load parts. The trade here ended up being to divide the rudder surface area into 4. Now, one last part of this weird rudder you may be wondering about. It says, what's the deal with this top tip? Kind of looks like a shark fin there. What's going on with that? It's near the hinge line, so it doesn't affect the balance, and it's kind of small to add much to turning. It looks like it serves absolutely no purpose at all. Okay, you got me. True confessions time. This shape of the top tip of the rudder serves no engineering purpose at all. It is pure Captain Nemo. It is perfect when you're deep underwater and on the lookout for giant squid. And hey, you want your submarine to look cool, don't you? And besides, if you think my submarine rudders look weird, you should see my airships. Be sure to subscribe to my channel, and thank you for watching. JP Aerospace, America's other space program.